Today in this video, let us perform an activity. This activity comes under the acids, bases and salts. In the previous video, we have seen that acids generate hydrogen gas on reacting with metals. That means acids have similar chemical properties. And that activity have shown that hydrogen seems to be a common element to all the acids. So today in this video, let us perform an activity to know whether all compounds containing hydrogen are acids or not. Okay, so we'll do an activity and we'll make a conclusion. Okay, the aim of this activity is to know whether all compounds containing hydrogen are acids or not. So now we'll perform an activity and will come to a conclusion whether the compounds containing hydrogen can be considered as acids or not. The materials required for this activity, we have to take some electric wires and some solutions, dilute hydrochloric acid solution, that is, and then H2SO4 solution, glucose solution, and alcohol, a beaker, some graphite, two graphite rods, and 230-volt AC plug, and a bulb. And by taking these materials, we'll perform an activity and see whether the compounds containing hydrogen can be considered as acids or not. First, we'll see the materials. Okay. Let us see the materials required for this activity. We need a few electric wires to make connection. So these are the electric wires. And we need some dilute solutions. This is a dilute HCl. And this is a dilute H2SO4 solution. HCl and H2SO4, both of them are acids. So always prepare dilute acids by adding acid to water. That is a concentrated acid drop by drop to the water. So that means we have to take a beaker and then you take some water in that and add few drops of concentrated acid to that beaker and then you stir it. But never add water to the acid because it is an exothermic reaction, heat is produced. So like that we have to prepare the dilute HCl and then dilute H2SO4 solutions. Okay, and the next one is the glucose solution. So take some glucose in the beaker and then you add it. So the glucose will dissolve in water. Okay, and the next one is some alcohol. You take some alcohol and then you add few ml of water to that. Okay, so like that we have to prepare the four solutions, that is the HCl, H2SO4, glucose and alcohol. And we require a beaker to perform the activity. This is the beaker, and you need a 230-volt AC plug. So this is the 230-volt AC plug, and you need graphite rods, two graphite rods. These are the two graphite rods, and we need a bulb. This is the bulb. Okay, these are the materials required. Now we will perform the activity. Now we'll do the activity. So first of all, we have to prepare solutions of hydrochloric acid, sulfuric acid, glucose and alcohol. This I told you. While preparing the acid solutions, we have to take the precaution, and that precaution also I told you. That is, first we have to wear gloves while preparing acid solutions, dilute acid solutions. And the second thing is, never add water to the acid. You have to add drop by drop acid to water, but never add water to the acid because it is an exothermic reaction. So like that we have to prepare the dilute acid solutions. Okay. And now we have to take a beaker. This is the beaker. Okay. So this is the beaker required. And now place two graphite rods in it. We have taken two graphite rods now. So we have to place those two graphite rods into the beaker. So now we are keeping the two graphite rods in the beaker. Right. So graphite rods are black in color. Okay. These are the graphite rods. Right. Then we have placed two graphite rods in the beaker. Now we have to connect electric wires to the two graphite rods separately. This is the 250 ml beaker. We have kept two graphite rods. Now we'll connect the wires to the two graphite rods separately. See, here we are connecting it. Okay. So to one of the graphite rods, we have connected the wire, and to the other graphite rod, we'll connect it. Okay. So now we have connected the wires to the two graphite rods separately. Okay. These are the electric wires. Right. See, we have prepared four solutions. No? Now we'll do the activity by taking each one, and we have to observe the activity carefully so that we can write our observations. Okay. Now first we'll do the activity with dilute HCl. We'll pour dilute HCl into the beaker. We'll take some dilute HCl into the beaker. See here already we have seen that we have prepared the dilute HCl, isn't it? So now we'll pour it into the this beaker. Okay, right. So we are taking dilute HCl into this beaker. So like this we have to do the activity for all the solutions. This is dilute HCl, right? The first solution we have taken is HCl. Okay, so this is the HCl which is in the beaker. Now we'll connect a bulb to one of the wires. We have to take a bulb and then we have to connect it to one of it, either here or here. Okay, right. Here we are connecting it. Okay, so this is the bulb which you are connecting to one of the wires, right? See here we are observing that this is empty. That means these are the free ends. Now we'll connect the free end of this to a 230 volt AC plug so that the circuit gets completed. Okay, so we'll connect the 230 volt AC plug to that free ends so that we'll complete the circuit. See, while working with AC, we should be very careful. I have already told you that while preparing acid solutions, we should be careful, and here while working with AC also we should be careful. Okay, now we'll try to connect the AC plug to the free ends, right? See, let us see. See, this is the AC plug. Observe it carefully. Yes, see, as soon as the plug is connected, the bulb has glown. That means here we have taken hydrochloric acid solution, dilute HCl we have taken. Here the ions are there, see, isn't it? So the ions are moving. So the movement of the ions make the flow of current, and so the flow of current leads to the glow of the bulb. So that means acid solutions contains ions. So the movement of these ions helps for the flow of current and makes the bulb to glow through the solution. That means movement of the ions helps the flow of current in the solution, so that that current will flow through the wire and then the bulb will glow. Here the positive ion, that is the cation that is present in the HCl, is H plus ion. Okay, so that means this suggests that acid produce hydrogen ions in solution which are responsible for their acidic properties. Okay, so HCl contains H plus ions. These H plus ions are responsible for its acidic character, and the movement of these ions will help the flow of current and makes the bulb to glow. Okay, so here you are observing the movement of the ions, isn't it? So this movement of the ions will help the current to flow so that the bulb is glowing. So whenever you are completing the circuit by connecting the free ends to the AC plug, immediately we have seen that the bulb has glown. So the glow of the bulb is due to the movement of the ions in the solution, which helps for the flow of the current. Okay, now we'll see with another solution. Okay, now we'll do the activity by taking another solution. So here the second one is the dilute H2SO4. Okay, now we'll take see, already we have placed the graphite rods, and the two graphite rods, they are connected to the whites separately, and now we'll pour H2SO4 solution into the beaker. Okay, we'll take some H2SO, dilute H2SO4. So first solution we have taken dilute HCl. Now we are taking H2SO4. Okay, right. So we are taking a H2SO4 solution into the beaker and perform the activity similar to the one which we have done for the dilute HCl. Right? This is dilute H2SO4. Okay, we'll continue the activity with this solution. Okay, now the same thing, we have to connect a bulb to one of the ends. See here, these are the two wires, one with one graphite rod and the other wire to the other graphite rod. And now we'll connect a bulb. Okay, so this is the bulb, right? Okay, so now again here we are having the free ends. Okay, so to the free ends, what we have to do, we have to connect the AC plug. Okay, we'll connect and see. For the first solution also, we have seen that we have completed the circuit by connecting it to the 230 volt AC plug. And for this solution also, for the dilute HCl solution, we have taken in the beaker. So and now also we will complete the circuit, the free ends to the 230 volt AC plug, and we'll see what will happen. So in the HCl, we have seen that the bulb has glown due to the movement of the ions. And now we have taken the dilute H2SO4, and now we'll see whether the bulb glows or not. See here, we are bringing the AC plug and we are going to connect it. Right. See, again as soon as the AC plug has get got connected to the wires, the bulb has glown. So the movement of the glow of the bulb is due to the movement of the ions. Here you are observing that the H plus ions are moving, isn't it? So these movement of the ions in the solution will make the current to flow so that the bulb will glow. So that means here in sulfuric acid, the positive ions that are present in the H2SO4 are also H plus. In the positive ions that are present in the HCl are also H plus. So that means acid, that is hydrochloric acid and H2SO4 sulfuric acid. These acids, they are having H plus ions in common. Okay. So these ions, or movement of these ions, they are responsible for the flow of current in the solution so that the bulb is glowing. Okay. So HCl, with HCl solution, the bulb is glowing. That means with the dilute H2SO4 solution we have taken, and here we have taken the H2SO4, and the first one is a HCl. In both the cases we are seeing that the movement of the ions is leading to the flow of the current, which makes the bulb to glow. Okay. So now we'll take the another solution and see what will happen. So now we are going to take the glucose solution. So the third solution is the glucose solution, and we'll perform the activity by taking this solution. We have to take a solution into the beaker, and then we'll continue the activity with this. So here already we have prepared the glucose solution. Now we'll pour it into the beaker. Okay, right? We have taken the glucose solution. Okay. See, in the first solution we have taken is dilute HCl, and the second solution we have taken is dilute H2SO4. In both the cases, the movement of the ions, that the positive and negative ions. In HCl, H plus and Cl minus ions, and in dilute H2SO4, H plus and SO4 minus 2 ions. The positive and negative ions are present in the solution. The movement of these ions, they are responsible for the flow of the current. So that means, but uh, the HCl and H2SO4, they have the positive ion in common, that is the H plus ion in common. But the movement of the positive and negative ions in the solution, they helps for the flow of the current. Now we'll see whether we are going to find any movement of the ions in the solution and whether we'll see the glow of the bulb or not. Okay. Now we'll connect a bulb to one of the wires, uh, just what we have done for the HCl as well as the H2SO4. Okay, yes, we have connected it. Okay, now the next thing what we have to do, we have to connect the AC plug and see. Okay, the next thing what we have to do, we have to connect the complete the circuit, isn't it? So now let us complete the circuit by connecting it to the 230-volt plug as usual, and we have to notice what will happen inside the beaker, and we should see whether the bulb glows or not, isn't it? So for HCl we have seen that the bulb has glown, and for H2SO4 also the bulb has glown. So we'll connect the AC plug and see. Right. See, we have connected the AC plug, but we didn't find any glow of the bulb. That means in the solution, ions are not present. The solution does not contain any ions. So if at all it contains ions, as soon as the plug is connected, the movement of the ions will lead to the flow of the current, so that the bulb will glow. But the bulb is not glowing. That means the ions are not present in the solution. We have taken glucose solution. So glucose solution does not give any ions in that solution. So because of the absence of the ions, the movement of the current or movement of the uh, flow of the current does not take place. That is the reason why the bulb is not glowing. So absence of the ions in the glucose solution makes the bulb not to glow. Okay, now we'll take another solution and see. Now we'll perform the activity with another solution, that is the alcohol. So first of all, we have to take some alcohol into the beaker. Okay, so this also we have prepared it already, and now we are pouring it into the beaker. Okay, so we have taken alcohol. This is the fourth solution. We have done with three solutions, and in the two solutions HCl and H2SO4 we observed that glow of the bulb, and in the glucose solution the glow of the bulb does not take place. Now we'll see with this also. Okay, now we'll complete the circuit by connecting it to the 230-volt AC plug and see. Okay, right. So now we'll connect it. See, see, we have connected the AC plug to the circuit, but the bulb has not glown. So that means here also we are not finding any movement of the ions. That means the solution does not contain any ions. Only if the solution contains ions, the movement of the ions will help for the flow of the current. So whenever the solution is not containing the ions, so no question of flow of the current. So here alcohol also does not contain any ions. Glucose also does not contain any ions. Only HCl and H2SO4 we have seen that they contain ions. So the movement of the ions will lead to the flow of the current. So the in glucose and alcohol, we are not finding any H plus ions in solution, whereas the positive ion, that is the H plus ion, they are present in H2SO4 and then HCl. So acids contain H plus ions in common, and these H plus ions, they are the characteristic properties of the acids. So the movement of the ions, that is the positive and negative ions that are present in the solution, will lead to the flow of the current. And the acids which contain H plus ions, they have same chemical properties. Okay, now we'll write our observation and tabulate them. Okay, now we'll write our observations. See, we have taken four solutions, isn't it? And for each solution, what we observed, we'll make a note of it. So first solution, what we have taken dilute H2S, HCl. Okay. And for that, what we observed, whether we have found any glow of the bulb or not. Yes, the bulb has glown, right? Okay. The second solution, what we have taken, second solution is dilute H2SO4. Okay. So here also we have observed that the bulb has glown. So S. And for the third solution, what we have taken? We have taken the glucose solution. And here we did not find any glow of the bulb. So no. And the fourth one, we have taken alcohol solution. And here also we observed that the bulb does not glow. Okay. So for these two solutions, we could find that the bulb glows, and for the glucose and alcohol, the bulb does not glow. Okay. So that means the acid solutions, they contain H plus ions in common. So the movement of the ions, that is the positive and negative ions in the solution, will help for the flow of the current. Okay. Now we'll make a conclusion. Now we'll make a conclusion. The acidity of the acids is attributed to the H plus ions produced by them in the solution. So that means the acids contain H plus ions which are produced in solution. So all the acids in solution will have the acidic character due to the presence of H plus ions in them. And the thing is, see, acid solutions, they have ions, and the movement of these ions is responsible. The movement of these ions in solution, this will help for the flow of the current. This we have seen for HCl and then H2SO4. That flow of current leads to the glow of the bulb. Okay, right. And the another thing is, the acids produce H plus ions in solution, which are responsible for their acidic character, responsible for their acidic properties. Whereas we have seen that glucose and alcohol, they does not contain any H plus ions, isn't it? So that means they doesn't have any acidic properties. Glucose and alcohol does not have any acidic property. Why? Because acids, they produce H plus ions in solution, which are responsible for their acidic properties. So glucose and alcohol does not produce any H plus ions because if it contains H plus ions, then only you will find that the movement of the ions will lead to the glow of the bulb. So the bulb does not glow. So that means glucose and alcohol does not contain any ions in them. Okay, and we can perform this activity by bases also, for like sodium hydroxide and calcium hydroxide. So there also we'll find that the movement of the ions will be there, and in bases, the common ion is OH minus ion. In acids we have seen that H plus ion in common, and in bases we'll find OH minus ion in common. So the solutions, the bases which contain ions in them, also they will help for the flow of current, because the ions, the OH minus ions which are present in the solution, will help for the flow of the current, so that we'll observe that the bulb will also glow. So we can do the activity with bases also. Cool. So I hope you understand. Thank you so much.